In this example, we've got a couple different word problems to solve. One of the keys when you're solving real life or application type or word problems is to figure out what you don't know. What you don't know, those are going to be your variables. Let's read this together, then we'll try to figure out what our variables are going to be. Fred and Wilma are siblings, but they are not twins. This means that they are not the same age. Wilma's 4 years older than 2 times Wilma's age. Maybe that's supposed to be Fred, we'll see. The sum of their ages is 19. Yeah, I think that's a typo. So this should be Fred here. Wilma can't be 4 years older than 2 times her own age. The sum of their ages is 19. How old is Fred and how old is Wilma? Well, this last sentence tells us exactly what our variables are going to be. We want to know the age of Fred and the age of Wilma. So let's let F equal Fred's age. And let's let W equal Wilma's age. You can work with uppercase letters if you'd like. I just prefer lowercase here when I'm solving for a variable, but it wouldn't make any difference. You could use A and B or X and Y, as long as you identify what each one stands for. This symbol on its own doesn't mean anything. If we define it, now it means something. Let's read this one again. Fred is, so we're going to write Fred is equal to 4 years older than 2 times Wilma's age. You could also write 2W plus 4 for this one. We also know that the sum of their ages, or F plus W, is 19. Now, it doesn't really matter which way you solve this. There's a few different methods to use, but I think this one is already set up for substitution. Notice we have F here on one side by itself and everything F is equal to. So we're going to take this F out and we're going to replace it or substitute with everything it's equal to. And you don't even need the parentheses here for this one. There's nothing to do out here. You totally need that if there was anything to the left of this F. But we can actually combine 2W and W to get 3W. We've got the 4 here. You can write it over there if you wanted to. We'll subtract 4. 3W is equal to 15. Divide by 3. And W here will be 5. If Fred is 4 more than or older than 2 times Wilma's age, and we think Wilma is 5, we can also do a little bit of arithmetic here, order of operations, and figure out what Fred's age is. So we've got 10 plus 4, which is 14. We've already defined our variables, so if you wanted to write this in sentence form, you could. But in this problem, F does mean Fred's age, and it's clear that Fred's age is 14, Wilma's age is 5. Does it make sense in the context of the problem? Always a good idea to check. Fred is 4 years older than 2 times Wilma's age. Well, 2 times Wilma's age is 10, and 4 years older than that is 14. The sum of their ages is 19. 14 and 5 is 19. Always double check your work and make sure that what you've written down for your answer makes sense in terms of the problem. Let's look at this one. It's a little bit more abstract. The sum of 2 numbers is 27. The larger number is 2 more than the smaller number. What are the 2 numbers? You might be able to guess and check with this one, but I'm going to have you develop a system to solve this. So let's let x equal the first number, and let's let, I know that doesn't look like a t there, let's let y equal the second number. It doesn't matter which variables you choose as long as you define them. So we said the sum of 2 numbers, so x plus y is 27. The larger number is 2 more than the smaller number. Let's see here. So that would be y plus 2. This one's also set up correctly for substitution, or if you prefer, you can do this method. I'm going to write the first equation down, and we're going to subtract y from each side. And that'll give us x minus y is equal to 2, just trying to show you a different method than the one we used above. You could add these together, so we've got 2x is equal to 29, divide by 2, and we find x to be 14.5, or 14.5. Now let's see what y would be. We know that x plus y, or excuse me, x is equal to y plus 2, so x must be 16.5. The larger number is 2 more than the smaller number, so that works there. And I think I made a whoopsie. I think I solved that incorrectly. I substituted for the wrong variable. Shoot, should have been the other way around. Actually, we should have been subtracting 2 here. So let's rewrite that. We'll just start again here. That's going to be x, which we found to be 14.5, is equal to y plus 2, so we'll subtract 2. Got it now. So the larger number is 14.5, the smaller is 12.5. When we add these together, we do get 27, so this does make sense.